Good evening, everyone. We, E-Construction and Design, have the pleasure to present the design of the Ormond Beach Environmental Learning Center. Our industry mentor is Dr. Mr. John Noble, and our faculty mentors are Lisa Spainauer and Dustin Davis. Our client is the City of Ormond Beach Leisure Services Department, and the main objective of this project is to create a space where people can be educated on the importance of protecting the environment. The design specifications were to come up with a layout of around 2,000 square feet within a budget of $400,000, a one-story building, and design the outer perimeter of this project. Perhaps the most important aspect of all was to make a building that would blend with its environment and be self-sustainable and environmentally friendly. This project is going to be located in Ormond Beach, right above Daytona. Specifically, it's going to be located right here. And as you can see, it is surrounded by residential areas and numerous water bodies. We decided to make a site visit, and it was possible to observe that the terrain was leveled and cleared due to the construction of a retaining pond, and our project is going to be located to the west of this retention pond. There is a lot of abundant vegetation and existing walking trails that will serve in the future for field trips and sightseeing. And the most important asset that this place can give us is a natural lake. So we wanted the building to take advantage of this view. So most of the building will be facing towards the lake, and most of the windows as well.
As requested by our client, we wanted to make the building Green Building certified. So we were going to go through the Florida Green Building Coalition. They have 8 categories that we can receive the 100 points that are necessary for certification. That's energy, water, site, lot choice, health, materials, disaster mitigation, and general categories. Some of the subcategories we were able to focus on were energy efficiency method and appliances, solar powered utilities, lighting efficiency, reuse of materials such as clearing of the site, and building materials that are eco-friendly and locally bought or produced. To begin with, we need to have an environmental impact study to be able to determine what we were working with at the site. And according to the ecological assessment report that was performed, we were able to determine that the land use classification was actually urban land in transition, meaning that the land had previously been excavated or cleared. Then we also determined that there was hydrate soil, which actually consisted of hollow claw sand and Tuscaloosa sand. And even though with the sand it was able to sustain large amounts of water given its location on the coast. And also found that there were some threatened animal species, not so much plant, but there were some water-wading birds we needed to take into consideration with our lot choice. And that was blue herons, tricolored herons, and snow egrets. So given the location next to the lake and the retention pond, we need to watch our construction process. And some of the regulatory agencies that we would be working with are Natural Resources Conservation Service, Florida Department of Environmental Protection, St. Johns River Water Management District, and also the U.S. Army Corps of Engineers.
Okay, so now I'm going to give you a little bit of background on our structural design. First of all, we had to take into consideration the client's main requirement of keeping minimum disturbance to the natural environment. In order to do this, we had to take consideration of the choice of materials so that we would reduce the overall construction waste, and also we needed to feature some techniques for reducing energy consumption within the building where we wanted to be a sustainable building. As far as the design criteria utilized, we mainly focus on the standards and guidelines provided by the Florida Building Code 2007 and the ASCE 7 minimum design loads for buildings and other structures. And we also had to take into consideration that we are located in a high-speed wind zone of approximately 120 miles per hour. Now, we created a little flow chart of our design process. First of all, we sat down with the client and identified their specifications. They wanted us to come up with the entire building concept from scratch, and then we decided to do a site investigation to identify the site constraints. We went on to obtaining the main design loads, which in our case are the dead loads, live loads, roof live loads, and the wind loads. Then we went on to determine the construction materials, which Since we wanted to reduce the construction waste, we will focus mainly on timber and steel rather than concrete. Then we went on to determining the floor plan layout and then designing the structural design to fit this layout. And then in the end, we went on to checking the chosen dimensions and shapes for adequacy against weight. Okay, so for the overall dimensions of the building, the total area is 2,000 square feet. And as you can see here, it has an L shape with two roof structures. The overall wall height to the roof eave is 12 feet, and the roof pitch has been decided to be 1/3 because we needed high pitch in order to account for ventilation purposes and to reduce the energy consumption rate of the building. The total height up to the tallest roof is 29 feet, and to the other one is 24 feet. Okay, another specification of our client was that we wanted to have large windows facing the lake so that the visitors of the center could get a feel of their natural surroundings. So we went on to designing 3 8.5 by 8 windows on the north wall of the building, and then 2 6 by 7.5 windows on the east and west side of the building.
For the layout, our client specified that he wanted an exhibit area, a display room, a prep area, and an office. So we managed to put all these items into our the available space we had within the layout. So here's the main entrance. Here is the office, the control room, the restrooms, one for men, one for women, display room, exhibit area, and prep area. Here is a 3D model of the layout. Next, we'll see a 3D model, an animated 3D model of our layout. Here is the main entrance. Here you can see the 2 restrooms, display room, prep area, the view to the natural lake, the office, and the control room.
Okay, so now I'm going to talk a little bit about the roof design. As I mentioned earlier, we needed to have a high pitch roof for the energy consumption rate. We chose to go with a pitch of 1/3, as I mentioned earlier, for the 2 roof structures, and we decided to go with timber trusses with material of southern yellow pine. And this first typical roof, the overall span is 42.5 feet, and the height is 14.5 feet. And the next one, the smaller roof structure, the span is 29.5 feet, and the overall height is 9.8 feet. And these both truss structures were designed to support a 1-inch thick plywood panel structure of southern yellow pine as well.
As we can see here, this is our RISA 3D model. We choose our wooden trusses, and our framing is going to be made of steel due to the length of our spans. Here we see a layout of all the main structural shapes we're going to be using. We can see the shapes of the beams, columns, and the column take plates we're going to be using. Okay, the next step on the design is going to be in the interior of the house. We're going to place a graded slab on grade. 2 important parts determine the endurance and the resistance of our slab, and it's the slab's thickness and the soil preparation. For the soil composition, we assume the composition of our soil inside from 4 borings done in 1998 by Universal Engineering Sciences for the construction of the pavement of Division Avenue. We decided to remove a topsoil of 1.5 feet to remove all organic matter, broken shells, and after that we're going to have a 5 feet depth of a soil layer of 5 feet depth of silted sand, in which we're going to place our slab and foundation for the house. Also, we're going to reduce the amount of trees removed to avoid some environmental impact. Some specification of our slab. Our concrete is going to be 4,000 psi. The slab thickness is going to be 6.5 inches, and for the moisture protection, we're going to use a 0.3 millimeters thick polyethylene film to avoid any moisture getting into the house and to the floor. Also, we're going to put a clay material of 2 feet wide next to the exterior walls to avoid any filtration from water coming from the roof. Here we see a layout of the areas in which the concrete is going to be poured. We're going to have 6 areas of 21.3 by 12 feet, and two front areas of 14.8 by 17 feet. And all the dotted lines we see are half-inch thick expansion joints to avoid cracking of concrete from expansion and contraction. Here we see the footing design. We decided to use a spot footing or a shallow foundation because of our lightweight structure. And it's going to have a column base of 8 inches. It's going to be square. And the footing pad is going to have 29 by 29 inches with a 7 inches thick.
Now, not only do we have to focus on the structure, but we also have to take into consideration the surrounding area outside of the building. And some of those included some walking paths. Well, upon our investigation, there are some existing trails throughout the park, but instead of creating even more anything, we want to focus on just maintaining those instead of disturbing even more environment. And we're also going to use mulch, and the mulch is going to initially come from the cleared brush of the site, and it's going to be used on the parking lot and on the walkway. And then also we're going to we can go back to the Tomahawk Farm Road landfill or West Volusia transfer station and get the additional mulch because they offer it for free from the recycling facilities. And per ADA requirements for the parking lot, the parking spaces were designed for the size of vans, and we also were gave 2 handicapped parking spots located closest to the building and closest to the walkway for easy access. Now we also are going to work on a deck on the north side of the building, which is the side closest to the lake, where the large windows are. Another way for visitors to come closer to the environment and actually enjoy the building and the surrounding area. And there's also going to be a canoe area. The park has a lot of canoers throughout their small lakes and the interconnection that they have. So we wanted to have an area where they could have access to the learning center as they're taking their canoe rides. So we're going to have about a 12-foot bank area that's been cleared of small brush so they can also come into the environmental center. We're going to take some landscaping into consideration. We want to restore and create some other habitats for the natural environment. We're going to plant some trees and shrubs and also some flowering plants. Flowering plants are going to help bring in some small wildlife and birds, and the shrubs and trees are going to help serve as wildlife cover.